All right. All right, class, let's go with this here. We're going to get into 2.2, but we're going to look at 2.1 first. And this one we didn't cover as much. So taking out your homework, let's see what we got here. We'll use this in 2.2. So this is 65. That's our problem, but I'm going to make a different problem off to the side right here. And let's solve this right here. If I say graph for me, or not graph for me, find me the zeros of this function. So, and anybody can factor those. 1 will be a 4. Knows, right? And you're just plugging in numbers, huh? In your head? Yeah. Okay. I'm going to go factoring here. So if I factor this out, let's see, I need two numbers. Multiply to negative 12, add to negative 1, all yours. 3 and 4. Almost, Luke. Give it off.
Negative
3 and negative 4. I'll go with that. All right. 3 and a negative 4 would do it. We good? That's the factoring process. Okay, so then what we'll do is we set each of them equal to 0. There's that one, and there's this one. And then we're going to solve them. This one just need to subtract 3, and we're good to go. This one we need to add 4, and we're good to go. So then we have this. So the next question is, what does that mean right there? X equals negative 3, x equals 4. Cool, okay. So Noah's saying, if you plug in negative 3 back into here, you're going to get yourself a 0. If you plug in a 4 back into here, you're going to get yourself a 0. The question to you guys is this. If I change the f of x just to a y, if I change it into this right here, and I say, look, if I plug a negative 3 in for x, you guys tell me what would be the y value? 0. Thank you. If I plug in a 4, what would be the y value? 0. So I'm looking at 1, 2, 3, that dot right there. 1, 2, 3, 4, that dot here. We good? What 65 is telling us, it wants us to go backwards. So notice if x is equal to 0, I'm sorry, x equal to negative 3 is the coordinate where it hits the x-axis. That means, let's go backwards here. That means if I set it equal to 0, sorry, I'm going to do this whole backward. Let me do this whole thing backwards then. If x is equal to negative 3, I add 3 to both sides to give me a 0. Hey, that tells me that's a 0. If I go over here, x plus 4, or x equals 4, and if I subtract 4 from both sides, that gives me a 0. So notice we have x plus 3 that's equal to 0, x minus 4 is equal to 0. So the question is this. If I were to multiply x plus 3 with an x plus 4, what would be the answer? I'm thinking a little differently here. Tell me if you guys agree. Because what is x plus 3 equal to? Over here.
Yeah.
It's 0. What is x minus 4 equal to?
Yeah.
So technically what I'm doing, I'm technically just multiplying 0 times 0, which is just 0. So when I multiply this out, x squared plus 3x minus 4x minus 12 still equal to 0. And eventually I got myself a x squared minus x minus 12 still equal to 0. Are we good? So when I look at this problem, now let's go to 65. See if that made sense. Let's go to 65. So I'm trying to get an equation of a graph that hits at negative 1 and hits at 3. And I actually need numbers, physical numbers here. So I'm going to say this. So you know what? One of my zeros or one of my solutions is x equals negative 1. I can add 1 to both sides and it'll give me x plus 1 equals 0. On this side, the other solution is x equals 3. If I subtract 3, it gives me a 0. if I were to multiply these guys together, it gives me a 0. So then if I were to really multiply these out, the binomial, let's see, -3 plus 1, that would be minus 2x, minus 3. Tell me if that's still true.
Yeah.
Okay, but here's the issue, is if I set them equal to 0 right here, I'm only referring to these dots when they're set equal to 0. What I want is I want a function. I want this function right here. Yep, the only change that we're going to have is going to say, hey, look, now it's going to become a function that actually has zeros at -1 and 3. Okay, there's the answer. We good? We'll have one extra little small problem. This one, just the a value here is 1. Is that true? I can stick in whatever a value I want because I can make this guy go down really like this right here. Remember, the a controls whether you have vertical compression or expansion, right? A could be like 1/2 or 1/3, and it'll come up like this. And that's cool too. We're good there.
I thought that for this problem, it was you needed to find an upward shift and a downward.
We'll find a downward in just a second here. So this one right here is like the most basic formula. That means a is equal to 1. We're good? If I wanted to still be the same zeros, I could also just choose this. I'm going to multiply everything by 4. 4x squared minus 8x minus 12. That will still give me those same zeros. Are we good? So that's why in the back of the book, doesn't say answers will vary, I think, or something like that, or no? So that's an answer. That's an answer. Both of them are positive. Both of them are opening upward. We're good. If we want something that opens downward, then the answer would be like this. Just multiply through by some kind of negative value. Could be -1. Oh, gotcha. No, because we're trying to put it into trinomial form. And so in this case, we just leave it as, let's see, f of x is equal to, let's multiply through the top one, the basic one, by -2. So -2x squared, positive 4x plus 6, is that right? Boom, so there it is. There's our function. Now it's opening downward. It goes twice as fast, but it still has those zeros at -1 and 3. Are we good? Okay, 65, 69. Let's go 69. Just want to make sure. So homework is good for that one, for 65 now. So hopefully you guys have your homework pages open. That's what we're doing. And we'll do something similar in 2.2. Okay, 69. This one has a fraction inside it, so it's going to look a little different. So 1, 2, 3. Here's my little dot. And then I also have a dot over here at -1/2. So I'm trying to think of two equations. One opens upward, one opens downward in order to. No, also you can, if you wanted to, you can just have a multiplier in front of the trinomial. That'll work too. Yeah. So I have x is equal to -3. We good there? Let's go with it here. That's true. Then what else is true? This one. Let's work with a -3 for now. If that is true, can I add 3 to both sides? I got myself a little 0. We good? Okay. Then we got this one. This one's a little more tricky. Let's talk about this one here because it has a fraction inside it. What we're going to do first, we're going to multiply by 2. 2x is equal to -1. What shall we do now? Add 1. 2x plus 1 equals 0. I got 2 zeros that are going to be multiplied together. And if you multiply zeros, they will still give you a 0. And now we can multiply this out. So how about a 2x squared? Let's see what this is going to give us. 6x here and another one here, right? So can I put 7x right away? Guys, will that work? Plus 3. And now instead of making it equal to 0, what I'm going to say is there's my function. with a being 1, there is my function. There's my upward graph. I'm going to multiply this guy by a -1 all the way through. This will be my downward graph. Done. I got both of them now. Okay, talk to me. Does that make sense? And we're able to finish up your homework for 65, 69 now. Okay, ooh, 20 minutes. Let's see if we can do 2.2 in 20 minutes. Huh, a little slider there. Okay, 2.2. Okay, after spending a long time in 2.1, polynomial functions of higher order. Polynomial functions of higher order. Boy, got some vocabulary here. So first things first, we're going to take a look at these two functions. Let's go with it here. So our main functions are going to be f of x is equal to x squared. Can you guys graph that one? And I'm going to graph another one called x to the third. So can you guys graph both these, and we'll talk about how these happen to be.
Is that all?
Of right here. Yeah, polynomial functions of higher order. So now we've been dealing with x to the second power. What we want to go is we want to go third, fourth, fifth. We'll keep on going. So how does all the stuff we did in 2.1 apply? So hopefully you guys did this already here. You have x squared. This becomes 0, 0. Is that right? This becomes 1, 1. This becomes 2, 2, 4. Everybody agreed there? This one becomes -1, 1, -2, 4. And the graph goes like this, comes on like that, touches the 0, and then comes right back up. Arrows at the end. All right. Okay, so that's our x squared. We've known this one for a while. Can you guys graph on the same axis x to the fourth? Whoa. So got dot, dot, dot. So hold on. Let's start off with x to the fourth. If I put -2 in, take it to the fourth power. That's already at 16, isn't it?
Yeah.
Yeah, that's way up there. So this graph goes way up there already. I'm not even gonna graph that. That's like all the way up there. If I take a -1 taken to the fourth power, just one. Yeah, so here, this guy just still hits 0. How about 0 taken to the fourth power? 0. So these two graphs have these 3 points in common. And afterwards, they don't have anything in common. So it looks like this graph will come down like this. And what happens actually right here is actually it turns right underneath that. And then it comes back out, it hits at the 1, and then goes up very, very quickly here. Good there. There's your graph there. Okay, how x to the third? Just want to see. You got 1, 1. And then once we get to 2, we're all the way up at 8, right, for this guy here. If you go -1, it becomes -1. So notice real quick here on the ones that have even powers, the negative goes away, doesn't it? The one that has odd powers, the negative stays because an odd number of negatives still is a negative. So I have this right here. It goes like, here's x to the third. It comes up like this. It kind of just turns a little bit like that. And then it curves the other way and just keeps on going. Starts from the bottom, goes back up, keeps on going. Okay, guessing. You guys have to little guess here. What's going to happen if you graph for me x to the 5th? Think about the numbers first. What 3 points do they have in common? Uh-huh. That point, that point, that point. And so if you're at -2 to the 5th power, like way down here, isn't it? Like way over there. And then let's talk about this one here. How about if you did like 1/2 to the 5th power? Right? Would it be higher or lower than 1/4? Yeah, let's do this here. You guys talk to me. 1/2 to the 3rd power, 1/2 to the 5th power. Which one's going to be a higher value? Oh, sorry. Oh, let's see. We're going to decide. Let me do it on positive side first here. So you're going to come down. It looks like it's going to come down like this right here, right? It's going to come down like this. So right here at the 1/2 marker, I just want to see 1/2 to the 3rd or 1/2 to the 5th. Which one's going to be higher? Which one's going to be lower? This is going to be lower. Everybody agreed there? So that means this little dot is going to be underneath here. So it looks like this. It comes down. It hits the 0 marker. It's a little bit higher than that. Then it turns. It curves faster. That's all. And it goes like that. Okay, what are we trying to get at here? And running out of time. So let's do this here. As if these guys are even numbers. Notice what happens with even numbers. On the negative side, if you square an even number, an odd number, it becomes, if you take a negative number and you take it to an even power, 4 or 6 or 8 or 10, the negative just drops out. Is that true? If you take a negative number to an odd power, 3, 5, 7, 9, that negative is still going to stay there. And so we have this little idea of something called end behavior on these guys here. So let's talk about this one here. The first rule that we get to here is it's called the leading coefficient test. Sorry guys, let me write it out so you guys can actually copy it over. There's 2 F's. I, C, I, E, and T. Coefficient test. All right, and it says this right here. If I have f of x and it's x to the nth degree, if n is even, here's what happened to my function. It's going to start off high, and I don't know what's going to happen on the inside here, but eventually it's going to end high as well. Tell me if you guys agree with that one. That's the ones that we just did there. And if n is odd, it's always going to do this. It's going to start off very low, and I'm not sure what it does here, where the points are, but at the end, it's going to finish off high. So for even numbers, for even powers, it starts high, ends high. For odd powers, it starts off high, ends low. Okay, good there. Next, another little problem. And how about this? You guys just put this in here. Just put a little A right inside here. Sorry, those are pins. I'm going to put a little A right inside here. I'm going to say this only works if A is greater than 0 or positive. Because what happens with A? You guys talking, what happens with the direction of A if I put a negative inside there? There's a reflection about what? The x-axis. Oh no, so hold on. Let's see if this makes sense. Next one, if A is an even, oh, sorry, if A is a less than 0 or a negative number. Speeding up here just to get us through. N is even, N is odd. And you guys talk to me here, previous function, previous graph, give me the reflection of the previous graphs. So I got this one to this one. So give me the reflection about the x-axis right here. It's going to start off right here, doesn't it? It's still going to start off low now. It's going to do this, whatever it's going to do. And then eventually it's going to go back to low. Where N is odd, it's going to start up high this time. And it's going to do something like this right here. And eventually it's going to finish low. Okay, 7 minutes to go. We're going to try to finish up a few things here. So this is called the leading coefficient test. Based upon the leading coefficient test, and if we can find any zeros, we pretty much have a good grasp of the function itself. We know which direction it goes at the ends, and then we really want to get the x-intercepts. And so 2.1, 2.2 are really just graphing polynomials, just getting a really good sense of graphing polynomials. Okay, let's try some here. So then we're going to go backwards here. So example 1, just graph. And we've got A. This one's probably a good one to do. Let's see. And again, just getting some kind of sense of things here. Yeah, that would be cool. F of x is equal to 3x to the 4th minus 4x cubed. So first of all, what kind of polynomial is this? Or what's the highest degree that you guys see? X to the 4th. So it's going to mimic x to the 4th as a polynomial. So right away, I think to myself, you know, it's going to start high and it's going to end high. That's it there. My next step is to find out any x-intercepts I have. So can I factor this guy? I think I can factor an x to the 3rd out of this, can I? X to the 3rd gets factored out. What's the leftovers?
Yes.
Yeah, 3x minus 4. Give me any x-intercepts here. I think 0 is in there, x-intercept. Everybody good there with 0? And this one needs to be solved for 0. So 3x minus 4 equals 0. That happens when we move the 4 over and we divide by 3, making it 4/3. Are we good there with 4/3? So if this is 1 and that's 2, 4/3 is about right there. Guys, essentially for polynomials, if you're trying to do a rough sketch of the graph, that's what you're looking for. You're looking for end behavior, which means it's going to start off high, it's going to end high, and it's going to go through these points right here. Sometimes what we want to do is we want to figure out what the y-intercept is, but for the most part, there it is. Okay, so how do we graph this? We have to go through the 0 marker. So as we go through 0, just real quick here, let's go back. Notice this is x to the 3rd power. So right at 0 or very, very close to 0, it's going to behave very similar to something that looks like this right here. See how it behaves at the 0? It's going to just kind of curve in, and it's going to be kind of like a nice flat line as it goes through the 0 marker. So that's kind of what you're looking for. So you're looking for not something that looks like that right here, right? But something more like kind of curves nicely into this like this right here. Boom. So then it needs to go through here. In order to reach the arrow on this side, it's going to curve out, and eventually it's going to have to turn around and curve this way, and then eventually get to the arrow. We may not get there. I just kind of stuck the arrow out here, but it's going to be about somewhere here. Are we good? Does that make sense as far as the graph is concerned? So in behavior, where does it end? And then where does it cross the x-axis? That's kind of what we're interested in. Let's do one more real quickly here. I'll do the work for you. And then we'll go backwards one time. So just B. So can we graph this one? So now notice this is not in graph form anymore. This is in trinomial form. And that's what we're trying to work with. We're trying to get to the easiest way to graph these. Looks yucky at first, but that's okay. We'll work with it in just a second here. So first things first, this guy, the highest exponent is a 3. So it's going to look like this right here, right? Except it has a little negative in front. So which way? Starts high, ends low, starts high, ends high, low, low, or high, low. I'm going to go with that. So starts high and it's going to end low. I'm not sure what's going to happen in between. So this is this one right over here. It's an odd number with a negative in front. Are we good there with that? Boom, boom. Cool. Next thing is trying to figure out the zeros here. So I'm going to do a little bit of work for you guys. I noticed this little 2 right here. So I'm thinking to myself, you know what? I hate fractions. So I'm going to factor out a 1/2 out of all this and just see what happens. In fact, because this little negative is right here, I'm going to factor in a negative 1/2 out of all this. And do we need to factor in the x? Yeah, we need to factor an x out of here. Okay, I'm just doing something real quick here for you guys, okay? Leftovers would be I'm going to go like this. Tell me if you agree here. Taking out a negative 1/2 x. X has to come out because x is in all of them. I take out a 1/2 because of the 9/2. And I'm taking out a negative because there's a negative all the way in front. Sorry, I'm going to do the factoring for you guys. We're good? So if that's the case, that is actually a nice little factoring process of 2x minus 3 to the second. It's a perfect square trinomial. Question is, how do we graph these? Let's go with it here. So I want this graph to start high. Eventually, I want it to end low. There's a 0 here, right? There's a 0 at 0. So I got this one. Also, there's a 0 where? If I add 3 to both sides, divide by 2, everybody okay with 3/2 or 1.5? Like somewhere here's another 0. We good there? Okay, and one thing to mention here with a minute and a half left, here it goes. Notice that you have, real quick, let's go back over here. Notice for powers of odd powers, notice that it actually goes through the 0. What happens when it's even powers? Looks like, it doesn't look like it just touches 0 and goes out of it again. So real quick, let's do this one. Like x squared. Let's go back up to here. Notice x squared next to the fourth. Does it cross the 0 or just touches the 0? It touches. X to the third, x to the fifth. Cross or touch? It crosses. In fact, if we just said g of x equals just x to the 1 power, it would have crossed. We good? Guys, real quick here, just 45 seconds here and we'll be good. So here, whenever you see an odd number or an even number, for even numbers, we know it's only going to touch the 0. We good? For odd powers, including 1, we know it's going to cross the 0. So here's what we do. We go with top. We're going to come in on the 0 like this. In fact, I'm going to scoot in a little closer like this. Because it's 1 power, it's going to cross here. And at positive 3/2, it's only going to touch. So I need to curve it back in. And I'm going to just touch this like an x squared would touch this. And I'm going to curve it back out. And do I finish at my arrow that I wanted to finish? Did. Cool. Okay. Okay, with 65 and 69, what we did over there, and with what we did over here with these two problems, you guys should be able to do 2.2. And I'm also going to give you guys a little, yes, let's try those. If we come back with homework questions, then we can, remember, it's not going to be due Wednesday, but at least start on the homework on Wednesday, for Wednesday's part. So we got test corrections for Wednesday, and at least start on the homework for 2.2.